Hello and welcome to part one of solving rational inequalities. In this part, we will be looking at the most basic type of rational inequality in the sense that the problem is already set up and ready to go. So we're mainly going to be focusing on the method that you use to solve a rational inequality. In the second and third videos, there are more advanced examples where the problem isn't set up and ready to go. It will involve a little bit more work, a little bit more algebra. So check those videos out also. All right, so what makes this problem set up and ready to go? Well, on the left side of the problem, we have one fraction. And that's what rational means, right? Rational is a fraction expression. Rational, fractional. There's a nice little rhyme to help you remember that. Rational, fractional. So that's the first thing, that the left side has one fraction, not two or more. And then secondly, the right side must be 0. If you don't have either of those, the problem is not set up and ready to go. So there's your little checklist. All right, one other thing to remember is that the numerator can equal 0, but the denominator cannot equal 0. And remember, the reason why the denominator cannot equal 0 is because in mathematics, division by 0 is undefined. All right, so let's go through our steps. Step number 1, we need to get the zeros of the function. And step 2, we have to determine where the function is undefined. So where am I going to get the zeros of the function? How about where the function can be 0? So the numerator will help you find the zeros. So it's simple enough. You take the numerator, set it equal to 0, and solve for x. So in this case, x equals 5 would be the 0 of the function. Where is the function undefined? Well, how about where the denominator is equal to 0? So remember the denominator, it cannot be 0. If it is, it's undefined. And you can solve this just like an equation by adding 1 to the other side, which means that x cannot equal positive 1. So in other words, the function is undefined at x equals 1. All right, now the next thing, you're going to set up a number line test, or a number line or a sign test, okay? So now on the number line, don't forget to include the infinity symbols because they may be helpful. And also don't forget, make sure you include the values from steps 1 and 2. So we need a 1 and a 5 on the number line. And the number line corresponds to any x value. On top of the line, we're going to put the sign of the y values. Well, what could the signs be? Well, obviously, positive, negative, and numbers that are not positive or negative are 0 or also just undefined. So right now we got two of them. X equals 1, we have undefined. I'm just going to write UND, save some room. Above the 5, that was the 0 of the function, so we're going to put 0 there. And now what do I have? These two numbers broke my line into 3 pieces, 1, 2, and 3. Those pieces are called intervals. So now here's where the sign test comes in. Remember, you pick a number x in that interval. So a number between negative infinity and 1 would be 0. And remember, do not reuse the numbers. In this interval would be like x equals 2, and in this interval would be x equals 6. So what you have to do is plug them into the function at the top of the screen, and then the value that you get, we'll call that the y value. And those are, when you plug in 0, you should get positive 5. Plugging in x equals 2, you get negative 3, and y equals 0.2 for the last one. 0.2 is also 1/5. Now what do I do with those? Remember, we are recording the sign of the y values. So in the first interval, the y value is positive 5. So we're going to put a positive sign there. The second interval, the y value is negative 3. So put a minus sign. And the third interval, y was positive 0.2. So now I'm just about done. Now at this point, I can at least write down that I'm ready to write out my solution. And I just have to remember, well, what do I look for to get my solution? I don't need everything on that line. So if you go back to the top of the screen and look at this, what does this mean? That the function is less than or equal to 0. Well, less than 0 means anything that's negative. And then the bottom symbol, that little bar, is the equal sign. So equals 0 is what that means. So now going back to my number line, circle along the top any negative signs or zeros. So there's 2 there. So that negative sign corresponds to this interval, and that 0 corresponds to x equals 5, which means we're including it. So that's when you put a solid dot or a bracket. If you go to x equals 1, it's undefined there, so that's an open point or a parenthesis. Okay, so remember, open points are parentheses, solid dots are brackets. And there you go. So the solution, therefore, we write it like this, little brace, and you write x. So the solution are all values of x, and then colon here means such that x is within the interval from 1 to 5. So in other words, that's just saying the solution to the problem is any x value in that interval, including 5 but not 1. So numbers like 2, 3, 4, 5 would be solutions, and any of the decimals in between. So there's your solution to that problem. I hope you found this helpful in reviewing the basics of solving rational inequalities. Again, remember to check out videos part 2 and part 3 of solving rational inequalities for some more advanced problems. I am the Math Musician. Subscribe to my channel and check out my other videos, Summer Math and Summer Music with me playing on the piano. Thanks for watching.